Dear students, in this class, let us discuss the H parameters which are very much useful to analyze the transistor circuits. You might have seen different types of parameters like impedance parameters, admittance parameters, ABCD parameters in your two-port networks. But out of all these, H parameters are very much convenient to analyze the transistor circuits. So, if you take a two-port network here, V1 and I1 are the voltage and current at the input port. V2 and I2 are the voltage and current at the output port. So, totally there are four variables that are available here, V1, I1 and V2, I2. Out of these four variables, two variables may be dependent and two variables may be independent. Suppose if you write the Z parameters, V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 V2 I2. Here V1 and V2 are dependent variables, I1 and I2 are independent variables. So this set is called as impedance parameters. Similarly, you can reverse it also, like in Y parameters. I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. So here I1 and I2 are dependent variables, V1 and V2 are independent variables. So that is Y parameters. Exactly like this, now I would like to define the basic equations of the H parameters. So in the H parameters, the basic equations are V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. These are the basic equations of our H parameters. Here H11, H12, H21 and H22 are called as H parameters. So if you observe closely, input voltage and output current are dependent variables. Input current and output voltages are independent variables. So here, if you see the logic of these H parameters, they will match the requirements of the transistors, because if you remember the way of writing the input characteristics as well as the output characteristics here. So whenever you are drawing the input characteristics, you are drawing the graph between input voltage versus input current, keeping output voltage constant. Exactly for the output characteristics, the graph is in between output voltage versus output current, keeping input voltage constant. That means they are actually depending on the input current and output voltage. That is the reason input current and output voltages are independent variables, whereas input voltage and output current are dependent variables. So these are the basic equations of the H parameters. Now coming for the definitions of the H parameters, once again write down here. V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. These are the basic equations just now I told you. Now I would like to define the parameters. So what is H11 here? H11 is equal to V1 by I1 when the other term is equal to 0. That means V2 is equal to 0. H12 is equal to V1 by V2 when V1 by V2 when I1 is equal to 0. I1 is equal to 0. Similarly, what about the H21? H21 is equal to I2 by I1, I2 divided by I1 when V2 is equal to 0, and H22 is equal to I2 by V2 when I1 is equal to 0. So just Observe closely, my dear friends. Here these two parameters are actually for V2 is equal to 0. That means whenever you are determining H11 and H21, you have to short circuit the output circuit. And whenever you are calculating H12 and H22, I1 must be equal to 0 means input circuit should be opened. Input should be opened. So now what exactly it is? H11 is equal to V1 by I1. Voltage by current means it is a resistance. What is the unit of resistance? Ohms. Ohms is the resistance. So the unit is ohms. That means it is the ratio of input voltage to input current means input resistance. So this can be called as in our transistor HI. HI means input resistance is equal to V1 by I1 when V2 is equal to 0. The unit is ohms. What is H21? H21 is nothing but it is the ratio of output current to input current. That means current gain. So current gain it is. So if you are taking this current gain, this is equal to, you can write down this is HF. Why it is called HF? Forward current gain. Current gain means the ratio of output current to input current, no units. So for this, no units. So this can be given as a HF, means forward current gain. If you take H12, it is the ratio of input voltage to output voltage. Actually gain means output by input, but here you are getting V1 by V2. Means reverse voltage gain. That's why it is called as HR, reverse voltage gain. What is the unit of this voltage by voltage? No units at all. No units. Exactly, if you are taking this H22, it is the ratio of current by voltage. Voltage by current is resistance. Current by voltage means conductance. Conductance means the unit is mhos, mho or Siemens, whatever it may be. So as it is the output side, output current by output voltage means it will be taken as HO. H22 can be represented by HO, H21 HF and H11 HI, H12 HR. Now if you observe closely, all these H parameters are having same units. HI is having the units of ohms, HF and HR no units at all, and HO the units is mhos. As you are combining different unit parameters at a single point, they can be called as hybrid parameters. Hybrid parameters. H means here, remember this is hybrid, means not at the same parameters. You are combining different parameters now. The parameters are having different units. That's why they are called as hybrid parameters. But whereas in your impedance parameters and admittance parameters, their units are same. In impedance parameters, what is the unit? Ohms. In the admittance parameters, mhos. But here, units are not same. So this equation I can write down here. V1 is equal to H11 means HI times I1 plus what is H12? HR times V2. And what about the second equation? I2 is equal to HF times I1 plus HO times V2. These are the basic equations of our transistor circuits. So if you remember exactly here, what is the first equation? This first equation is telling it is voltage is equal to voltage plus voltage, means it is telling about KVL. The first equation is KVL and the second equation is nothing but the KCL. One is KVL and other one is KCL. So input side representation of the transistor is KVL. Output side is KCL. And it is a Thevenin representation, input side. Thevenin representation means a voltage source in series with a resistance. And what about the output equation? This is telling about the Norton representation. So generally you can expect a voltage source in the input side and current source in the output side. Now I will draw these circuits. I will implement these two equations in a circuit form. So let it be plus and minus. This is V1 and this is V2, output port. So what exactly it is? V1 is equal to HI times I1. This is HI means it is a resistance. Just now I told you. This is HI times I1. I1 is the current flowing through this, plus HR times V2. HR is no units, V2. It is a voltage source. That's why I can draw like this. It is a voltage source, plus and minus, and it is a common terminal for the input and output port. So this is HR times V2. HR times V2. This is plus and minus. Now you see the first equation is implemented. V1 is equal to HI times I1 plus HR times V2. What about the second equation on the output side? It is a Norton representation I2. So let it be, this is the I2. I2 is the current flowing through this. This I2 should be equal to, this I2 is equal to HF times I1. It is a current source. This is the current source whose value is HF times I1 plus HO times V2. HO is an admittance. This is HO. HO times V2. So what is your I2? I2 is equal to, this is the I2. I2 is equal to sum of this current and this current. It is a KCL. I2 is equal to HF times I1 plus HO into V2. HO is an admittance. Admittance into voltage is nothing but the current. That's why this is the way of actually giving a model for your H parameter equivalent circuit. So what are the basic equations? V1 is equal to HI times I1 plus HR times V2. I2 is equal to HF times I1 plus HO times V2. So this is the first equation and this is the second equation. So this is the way of drawing the diagram. Very simple. Whenever you are drawing this H parameter equivalent model, very simple. Take a circuit and voltage source on output side, on current source in parallel with your resistance. So like this you can say. So already you know your voltage source should have a resistance in series. A current source will be having a resistance in parallel with this. The same representation we are giving here. So this is the way of writing the equivalent circuit model of H parameters. Now, suppose for example, we are using this equivalent model. It is a general model for different types of configurations. Let it be. There are three configurations in our circuits. One is CB and other one is CE and C. Now you can say the H parameters you can convert like this. Suppose if it is the common base, it is HI, it is generalized model. That's why I am just implementing this HIB for common base, HRB for common base. This will be HFB and this is HOB. So HIB, HRB, HFB and HOB for which configuration? Common base configuration. So what I am telling is, whatever the analysis I am telling to you, the same analysis is actually valid for all types of configurations. It may be common base, common emitter or common collector. So you can ask me, sir, what is this V1 and I1 then? So very simple. You take common base here. So just to avoid the confusion, take common base here. Common base means base is common and emitter is the input and collector is the output. What is the input current here? IE, emitter current. What is the output current here? IC. Input voltage is VEB and output voltage is VCB because it is the voltage between the collector and base here. Collector and base here. So, now what is V1 here? I am using for common base configuration. What is V1? Input voltage. What is the input voltage? This is VEB. This will become VEB. This is VEB. And what is the input current here? IE. I1 means it is equal to IE, emitter current here. HRB, V2, what is V2? Output voltage. This is VCB. That means HRB times VCB. Okay. And HFB times I1. What is I1? IE. So HF1 times IE. HFB times IE. HOB times what is V2? V2 means it is VCB. So this is the way of converting your generalized circuit for any configuration. Very simple. Just add one subscript here for the other configurations. HIB, HRB, HFB and HOB. And you can mark your input voltage and input current for this. Then it becomes common base configuration. Exactly. For common emitter what happens? For common emitter means HIE, HRE, HFE, HOE. What is the input voltage for this common emitter? This is VBE and this may become IB, input current. So output current is IC and you say output voltage is, you can say that output voltage is VCE. So like that you can convert your generalized configuration to any configurations. So it is a generalized network. It can be utilized for any type of configurations. Okay. Now I would like to calculate the important parameters for this generalized network. Then I can apply the generalized network for any type of the configuration. So we are going to calculate it now. What is the current gain, input resistance, voltage gain and output admittance. Now we are going to calculate the current gain AI, input resistance Ri, voltage gain AV, output admittance Y0, current gain with source AIS, voltage gain with source AVS for this generalized H parameter network. So just now I told you the basic equations of this H parameters are V1 is equal to Hi times I1 plus HR times V2, this is the KVL. I2 is equal to HF times I1 plus HO times V2. So we have implemented these two equations in this diagram. Input side is KVL and output side is KCL. Now this is the H parameter representation of the generalized network. Now for this network, I would like to add the input as well as output. So now I am adding input source for this. Let the source resistance is Rs and the source voltage is plus and minus Vs. You are connecting the voltage source to this input network, and for taking the output, I am just adding a load resistance RL for this. This is RL. The current through this one is IL. The voltage that is producing across this one is V2 as usual. Now coming for the first parameter, current gain. What is current gain? Current gain means, what is the current gain? Current gain means output current by input current. So the definition of this current gain is AI is equal to output current IL by input current is I1. What is IL here? IL and I2 are in opposite directions. So I can say IL is equal to minus I2. So this is equal to minus I2 by I1. Therefore, current gain AI is equal to minus I2 by I1. That is equal to minus of, in the place of I2, I can write down the second equation, HF times I1 plus HO times V2. So I2 is equal to HF times I1 plus HO into V2. So I can say that HF times I1 plus HO times V2 divided by your I1. So that is equal to I1 and I1 will be cancelled, minus into HF plus HO into V2 by I1. So what is V2 here? What is V2? V2 means voltage across this one. Voltage across this one is IL into RL. IL into RL means IL is minus I2. So minus I2 into RL. So this is equal to minus of HF plus HO into V2 means minus I2 into RL divided by I1. So you see minus I2 by I1. What is it by minus I2 by I1? It is nothing but the current gain by definition. Therefore, finally I can write down AI is equal to minus into HF plus HO into minus I2 by I1 means AI into RL. AI into RL. So what is AI? Here you see minus 8 I2 by I1. So this minus also will be there. So this will become minus. So if you take this one, that is equal to AI into 1 plus HO into RL is equal to minus HF. So what is the current gain here? Therefore, current gain AI is equal to minus HF divided by 1 plus HO into RL. This is the generalized equation for the current gain. Simple. Taking the definition of the current gain, actually we have developed this expression. So from now onwards, current gain A is equal to minus HF by 1 plus HO into RL. I already told you, all these expressions are equally valid for all configurations. Suppose if it is for common emitter, AI is equal to minus HFE divided by 1 plus HOE into RL. That means for the common emitter configuration. So now we are producing actually, we are developing generalized expressions. Once the current gain comes into the picture, already you got the current gain now, AI is equal to minus HF by 1 plus HO into RL. Whenever you are doing the problems in future also, you follow the sequence. First find the current gain, then the input resistance, then voltage gain, then why not? So the next objective is input resistance. So what do you mean by input resistance here? This is the input voltage V1 and this is input current. So if you are seeing from this place, this is the voltage and this is the current, then this will be Ri, input resistance here. So you are seeing in this direction. So what is the definition of Ri? Ri is equal to V1 by I1. So I can say that here, input resistance Ri is equal to V1 by I1. What is V1? What is the first basic equation? What is V1? HI times I1 plus HR times V2. That is the first equation. So I can say that this is equal to HI times I1 plus HR times V2 divided by I1. So your Ri is equal to I1 and I1 will be cancelled here. So HI plus HR into V2 by I1. What is V2? Output voltage. Therefore, Ri is equal to HI plus HR into V2 means output voltage, IL into RL. What is IL? Minus I2. Minus I2 into RL. So, minus I2 into RL divided by I1. So, what is the definition of this? Minus I2 by I1. If you are taking this factor, what is this? It is nothing but the current gain. Therefore, Ri is equal to HI plus HR into AI into RL. This is the second expression that is required, that is the input resistance here. So if you observe closely, the input resistance is actually having AI also. So that's the reason first calculate the current gain for any circuit, then substitute here, you are going to get your input resistance. Now two parameters are completed, current gain as well as input resistance. Now what is voltage gain? The third parameter I am telling you, voltage gain. Voltage gain means output voltage by input voltage, that can be represented by AV. Gain is always represented by the letter A in electronics. AV is equal to output voltage V2 by V1. Therefore, this is equal to V2 by V1. Therefore, I can write down here AV is equal to V2 divided by V1. What is V2? Minus I2 into RL divided by, what is V1? V1 means input voltage. This is the input voltage V1. Remember here, this is the input voltage V1. V1 is equal to input current into this total resistance. Just now I told you, whenever you are seeing from this entire network can be converted into input resistance Ri. So whenever you are seeing from this input side, it becomes Ri, input resistance Ri. So Ri into I1 is nothing but your V1. So I can write down, in the place of V1 I can say this is I1 into Ri. Therefore, what is the voltage gain AV? AV is equal to minus I2 by I1 means AI, current gain, into what is RL by Ri? RL is the load resistance, Ri is the input resistance. So this is the expression for your voltage gain. So you see, voltage gain AV is equal to AI into RL by Ri. So in this expression, you have taken the help of both current gain and input resistance. That's why I am telling you the technique of doing these problems. First find the current gain, then the input resistance, then voltage gain. So these are the three expressions we got here. Now we have to calculate what is the output admittance. So whenever you are seeing from this, what is the admittance you are getting here? Okay. So now we are going to do this. Now we are going to calculate the output admittance. Output admittance is defined as Y0 is equal to output current by output voltage when the internal sources are set equal to 0, Vs is equal to 0 and the load resistance should be equal to infinite. So, this is a condition you have to impose while you are calculating the output admittance. That means, whenever you are seeing from the output network, the internal sources must be equal to 0. No source should be present there. So, now you are going to write the expression here. Your y naught is equal to I2. What is I2 from the second equation? HF times I1 plus HO times V2 divided by V2. So, that is equal to HF into I1 by V2 plus HO. So, now what is this I1? What is this I1? Input current. Input current you have to calculate whenever the source is equal to 0. So, whenever the source is equal to 0, that means whenever the source is not present, and if you are short circuiting like this, no source is present, then write down the KVL for this. What is the KVL for this? The KVL what you are writing here is, you can write down RS plus HI into I1 plus HR times V2 is equal to 0. This is the KVL. No source is present. RS plus HI, both are resistances. They are in series. RS plus HI into I1 plus HR times V2 is equal to 0. So, from this I can write down RS plus HI into I1 is equal to minus HR into V2. What I require there? I1 by V2. I require I1 by V2. Therefore, I1 by V2 is equal to minus HR by HI plus RS. Just substitute this in our requirement here. You are going to get Y naught is equal to HO minus HF into HR divided by HI plus RS. This is the expression for the output admittance. Output admittance means it is having the unit of mhos. So, the unit is here mhos. Here HO, HF, HR, HI are the H parameters, and this equation is also can be used for any type of the configuration. Okay. So, once you get this, then our duty is to get, and next thing is we are going to calculate what is the current gain with source and what is the voltage gain with source. So, I would like to define AIS. What is the current gain with source? AIS is equal to, with source is equal to output current IL. So, for this the output current is IL by this is IS. Now, this is IS. So, you can say IL by IS. What is IL by IS? That is equal to minus I2 by IS. Minus I2 by IS. So, I can write down here minus I2 by I1 multiplied by I1 by IS. I can write like this because I1 and I1 will be cancelled. Therefore, AIS is equal to, what is this first parameter? Minus I2 by I1, current gain AI multiplied by I1 by IS. Now, I have to calculate what is this I1 by IS from this network. So, if you take this network, this entire thing will be represented by the input resistance from these two terminals. So, I can give a circuit here. So, this is Vs and the series resistance is Rs, and you can say this is the thing is totally, this is Ri, input resistance Ri here, this is Ri. So, this can be represented like a, this is nothing but as Rs, okay. This is a Thevenin representation, but I want to go for this current gain. So, write down the Norton presentation, this will be equal to, what is the Norton presentation here? A current source in parallel with a resistance. So, this is IS and this one is RS and that this one is RI, input resistance of the network. So, I would like to have I1 by IS. What is I1 here? I1 is through RI, this is. So, this is the current I1 and this is IS through resistance RS. So, you have to use the current division formula here. So, you can say that what is I1 here? I1 is equal to, I can write down from this, I1 is equal to, the available current Is into other branch resistance means Rs divided by sum of the resistances Ri plus Rs. Ri plus Rs. So from this, what is I1 by Is? Rs by Ri plus Rs. So that thing you have to substitute here. Therefore, AIS is equal to current gain with source is equal to current gain into I1 by Is from this. What is I1 by Is? Rs by Ri plus Rs. Ri plus Rs. So this is the current gain with source. This is the formula. We are going to find the last and final parameters, voltage gain with source. So voltage gain with source, AVS is equal to V2 by Vs, output voltage by the source voltage. That can be written as V2 by V1 multiplied by V1 by Vs. So what is V2 by V1? It is nothing but the voltage gain AV into V1 by Vs. So as usual, take this circuit here. What is V1 and what is Vs? V1 means the voltage across is Ri. This is voltage. So you can write down what is V1 from this. V1 is equal to Vs divided by total resistance Ri plus Rs multiplied by Ri. Therefore, what is V1 by Vs? You take the Vs to this side. V1 by Vs is equal to Ri by Ri plus Rs. You substitute it there. Therefore, this is equal to AVS is equal to AV multiplied by V1 by Vs. V1 by Vs means Ri by Ri plus Rs. Ri by Ri plus Rs. So this is the voltage gain with the source. So now if you see this here, if you put Rs is equal to 0, no source resistance at all, if the source is ideal, no source at all, this Vs is equal to V1. So if you put Rs is equal to 0, R and R will be cancelled, AVS is equal to AV. Voltage gain with source and without source are same. If the ideal source if you are taking, what do you mean by the ideal source? Rs must be equal to 0. So this is the way of calculating different types of parameters for our two-port network, that is for our H parameter model: current gain with source, voltage gain with source, input resistance and output admittance. So now for the ready reference, I would like to summarize all these equations, so which are very much useful for all these configurations. So the current gain AI is equal to minus I2 by I1 is equal to minus HF by 1 plus HO into RL or ZL, whatever it may be. If in the place of RL, you can take ZL also, impedance. Once A is available to you, I can say input resistance Ri is equal to HI plus AI into HR into RL. This is the second expression. Once AI and RL are available, then I can say AV is equal to AI into RL divided by Ri. Then the output admittance Y0 is equal to HO minus HF into HR by HI plus RS. This is the output admittance formula. Then finally, I would like to write down with source also. What is with source? AIS is equal to AIS. Current gain with source is equal to some current gain into Rs divided by Ri by Ri plus Rs. Similarly, voltage gain with source AVS is equal to AV into Ri divided by Ri plus Rs. So these are the formulas you have to remember for doing any type of the problems. Friends, all these equations are equally valid for all types of configurations. Depending upon the H parameters, you can calculate all these parameters. So for example, I am telling you for common emitter configuration, if you want to do this, AI is equal to minus HFE by 1 plus HOE, HFE by 1 plus HOE into RL. RI is equal to HIE plus AI into HRE plus RL. AV is equal to AI into RL by RI. So Y0 is equal to HOE minus HFE into HRE by HIE plus RS. AIS is equal to the same thing. So like this, you can utilize all these generalized equations for all types of configurations. So I hope you understood how to calculate all these parameters for the H parameter model. Once you know this H parameter model, it is very easy to calculate all these parameters for any type of configurations, like your common emitter or common collector configuration, which is also called as emitter follower. I hope you understood this. Thank you.